everybody, this is Mr. Munson, and this is just a simple review for the benchmark number 3 or number 4. So if you look down in the description spot of the YouTube video here, you'll see a document, and so you might want to go ahead and download that document and print it up and take a look at some of these problems. That way you don't have to draw them. All right, let's go ahead and get started. Now, for the most part, what I'm going to do is I'm going to show you a picture of a problem, and then I'm going to ask you to put me on pause and think of the questions that I might ask you about that problem. Then I'll slowly display them over on the other side. Then I'm going to scroll down and I'll show you the answers to many of those problems. It'll be simply that, not a whole lot of talking. You'll be able to look at my work and hopefully decide or see how I've done the problems. Obviously, you should do the problems on your own first and then use my work to check your work. All right, here we go. Go ahead and put me on pause and see if you can think of some questions I could ask you about this problem. All right, welcome back. And so I certainly could ask you to find X or maybe A, really any one of the angles I could ask you to find. All right, go ahead and see if you can answer those, and then put me on pause and come back and I'll have scrolled up the answers. So you can just put this on pause if you want to have that handy to you. Otherwise, we're going to move on to a new problem. All right, put me on pause and see if you can think of the questions. All right, put me on pause and see if you can do those problems on your own and come back and check your work. Just to add to one that you could do in your head, probably to find the height of the building, we would have to recognize that that 10 feet there is the same as the 10 feet on the bottom of that square. And if it's at the same at the bottom, then we would put it on the side. And of course, then now we just simply add the 30 plus 10 plus 30 plus 10. That gives you 40. Most of these problems, I'm trying to get you to strengthen your ability to problem solve. Can you go find answers to problems that require you to go find answers to other problems first? And so you're going to have to start asking these questions on your own. What do I need to find this final outcome, the height of the building or whatever? All right, see if you can come up with the questions. Okay, so those are just some of the questions I could ask you. Pretty much find any angle, right? All right, see if you can do the problems and find the work on your own. Come back and check your work in just a minute with my work. Now, obviously, once I find out that X is 10, I can plug that 10 into any one of these angles that have X as the answer. That'd be 60, that'd be 120. Then to find Y, what I have to do is look at a couple of different relationships. I could look at these opposite angles in a parallelogram are congruent. So I could just set 3Y equal to 120 and solve for that. The equation that I wrote over here goes along with the idea that this is 60. And if that's 60, then these two are supplementary because they're consecutive interior angles. That gives us 3Y plus 60 equals 180. Okay, here's the next one. Take a look at this one, see if you can come up with some of the questions I might ask you. Okay, I certainly asked you to write an expression for this segment right here, this length. I'm just going to go ahead and take care of that right now. This is what I would know. I could take that entire length, 77, which is the 2 segments, and subtract away X. This would be a decent expression for that segment. Okay, what's the other question? Well, hopefully it's find X. Go ahead and put me on pause. See if you can do that problem on your own. Come back and check your work. Here's 2 different ways that you could do that problem. One using that 77 minus X, the other one just using the 77. Again, as you're walking through this, if you're not sure how this is going about, go back and look at these sections and the notes for these and see if you can figure it out from that. Here's the next one. What are the questions I could ask you here? Among other simpler questions, right? Yeah, we could ask you any side, actually. All right, go to work. All right, welcome back. I also could ask you to find the perimeter, which of course, if you walked into this problem and that's all you had, you would have to go find y and find x, right? You'd have to go find those things. So you need to know when you see a question like this, what are the steps to solve and get into this final answer? And of course, it would be finding x and possibly finding y. Find the perimeter, that would be a good question, wouldn't it? So how would you go about doing that? Well, you need to find, of course, TR or RT. These are some other questions I could ask you, couldn't I? Now, when I'm talking about identify the triangle, I mean by the side information and by the angle information. We've done this for a long time. So it'd be looking at this. You definitely know from the column of angles, you look at the angle, that would be called a right triangle. From the column of names for the sides, well, I guess you're going to have to find out what RT is to see if it matches the 17 or not. Or if it's different, then obviously it'd be all the sides are different, which gives you a scalene triangle. Lost you for there for a second. All right, put me on pause. See if you can answer those questions and then come back and check your work. Get this stuff out of the way. Well, I forgot to hide my questions, so there they are, right? So go ahead and put me on pause. Come back and see if you can answer those questions. Now, since this is an angle bisector, we know that from a section that we did back in the day, it creates four segments. We have this segment, of course, and this segment already done, but it takes this side and breaks it up into two pieces. And so what ends up happening is all four of these pieces become proportional. That means I can write a proportion. So I'm going to have 11 over the piece that's next to it. We'll pause there for a second, come back and come up with that one. Is equal to this piece, 14 over x. Okay, so you can come up with an expression to write for that missing side there. Put me on pause and see if you can do it. All right, you should add something like 20 minus x. All right, here's the solution. And there you have it. Moving on. Now keep in mind, you don't have to watch the entire video. You can just look at the problems that you feel like that you might struggle with. All right. Can you come up with the questions? Now definitely you know that it's a right triangle. And you know that if that side right over here is 6, then since that angle and that angle is going to be 45, of course, we know this is a 45, 45, 90 triangle. If that one side's 6, then BC is 6. Now you have an isosceles trapezoid. I mean, an isosceles triangle. So you have a right triangle and isosceles triangle. All right, see if you can find x and the length of BC. Go ahead, try to get the questions. I definitely know it's 30, 60, 90 that gives it a right triangle flavor. And since all the angles are different, 30, 60, and 90, that tells me it's going to be a scalene triangle. All right, so off you go to find AB and AC. All right, so you should drew your reference triangle. AC ends up being 10. Here's a cool thing. So I'm starting to see a pattern. Since the side that was given was the 5, across from the 30, right? You look at it, it's right across, it's opposite the 30. That one tells me that the 5 and the 1 go together, right? Because they're in the same perspective. So what I know is that the black triangle is 5 times bigger than my reference triangle. That means every side is 5 times bigger. Now this only works if they give you the side across from the 30. So now I know that this triangle is 5 times bigger, then every side is 5 times bigger. That means AB is 5 square roots of 3. The square root of 3 on my reference triangle times 5. All right, see if you can figure that stuff out. I've done this problem quite a bit in class, so hopefully you remember the formula for this one. It has to do with the exterior angle, and there are 2 remotes. See if you can write down the equation. The questions that maybe I should ask is find x, maybe find a, really find any angle. Of course, I would just simply use this x equals 5. I plug it in to find any one of those angles. I could even use it to find this angle by first plugging it into here, and then using my linear pair postulate that these 2 angles right here have to add up to give you 180. Put me on pause, see if you can find that stuff. I just look at this, it might be a little bit difficult to figure out what the question is. So what additional information would you need in order to show the 2 triangles are congruent? By angle, side, angle. And certainly I could ask you for side, angle, side. I could ask you for angle, angle, side, and all that stuff. Okay? So see if you can figure out what is the information you need to get from me to prove that triangles are congruent by angle, side, angle, and a different problem, side, angle, side, and so on. Put me on pause and see if you can do that. And certainly these 2 angles right here are vertical and they're going to be congruent. So looking at angle, side, angle, all I know is that that comes for free. You don't need to ask me for that. So there's the first set of angles for the A. Then I have a set of sides already given, so I don't need that. To go angle, side, angle, the last thing I need is this pair of angles to be congruent to this pair of angles. Okay, so the answer to the question would be, I need to be given, you would need to be given angle U is congruent to angle, I think that's a K, maybe an R. All right, for side, angle, side, very similarly, same stuff as there, but for side, angle, side, I have this pair of sides already, and I have this pair of angles, so I just need another pair of sides to make it so that the angle is trapped between the 2 sides. So it'd be that one and that one. I could do that with angle, angle, side as well. All right, see if you can do those. Specifically, see if you can come up with the equations that you're going to need before starting them. All right, how about this question? How about this one? And then this one. Probably the thing you would want to do is start off by drawing your own triangle. All right, put me on pause. Let's see if you can do this one. And there you have it. Now I chose to do the orders smallest to largest because there was nothing said if it should be smallest to largest or largest to smallest. Okay. Now obviously this ordering. All All right, and so to order the sides, I'm going to look at the angles. And across from the smallest angle is the smallest side, right? That's how I did it. What do you think the question is? Okay, so looking for the third side. The third side can be either too small or too big. We have to be careful. And so there's a range that we're going to do about this. So if you weren't sure at this point and you now know, just put it on pause and see if you can walk through the rest of this problem on your own. All right, so that's simple. It really is. You subtract the 2 and you get 7. And then you add the 2 and you get 27. Now what this is saying is that the third side has a range between 7 and 27. It can't be 7 and it can't be 27. It can be anything in between there. All right, see if you can come up with the question. Okay, so you're going to solve for the x. You get x equals 7. Then you just plug it in for the sides, and across from the smallest side is the smallest angle, right? Now in this case, we have an isosceles triangle because both of these are 41. So there's kind of a tie for the next size angle. That's why I have them stacked on top of each other. Then I'm asking you to identify what kind of triangle it is by its angles. To do that, remember the Pythagorean theorem converse. Pythagorean theorem converse is if you have a right triangle, then you know that a squared plus b squared equals c squared. The converse is switch the positions, just like we've learned. And if a squared plus b squared equals c squared, then it's a right triangle. So using that idea, we use what I called the Pythagorean theorem converse, or the three varies. So I walk through that and I find that the side that I think is a hypotenuse is too small. All right, and that makes it an acute triangle. All right, let's go on to the next one. All right, here's the next question. See if you can figure out what the questions are. All right, see if you can do that one. Okay, so there's your answers. Now, x equals 12 is obvious there. So what I did is I took that 12 and I substituted in for each of the angles, and I got these angles here. So now across from the 22, which is the smallest angle, is the side AB, and I just ordered them according to the sides. Let's put a bar for that. All right, very good. Let's go on the next one. Put me on pause, see if you can do that. Keep in mind that the standard equation for a circle is of the form x minus h, y minus k, and then the radius is being squared there. And I've given you a hint what's going on there by accidentally leaving that 6 squared there. And there you have it. All right, here's your next problem. All right, what would be the questions I might ask you for this? I could ask you to graph a parallel line through the given point. The given point, if you can't see it from your device, it's right up here. And I could also ask you to draw another line through the point that's perpendicular to that. Okay, see if you can think this one up on your own. Come back and check your work. I would do it by finding the slope of the original line. In this case, it's 3 over 2, but it's negative, okay, because the slope is negative. So I either have negative 3 over 2, or it's 3 over negative 2. Either way, I just need to have a negative in one of those numbers. Now to do the parallel slope, I'm just going to copy that same slope up to the point that's up here. So I would go up 3, and in this case it takes me off the page, and I would have to go over negative 2. Since that's going to happen, I'm actually going to use the negative 3, 2. So I'm going to go down 3 and positive 2. And so there's my line for parallel. If I was doing the perpendicular slope, then the perpendicular slope is opposite reciprocal. Since the original one's negative, we'll make this one positive, and then we'll flip the numbers. So go up to your point, go up 2, and then positive 3, and that will create a perpendicular line. All right, that's it, and I hope that you have a fantastic day.